Hello everybody. In the last video we showed that the generating function for 2n choose n. So in other words, we have an infinite polynomial with these kind of terms. That this was 1 divided by the square root of 1 minus 4x. Okay. So what let's think about Catalan numbers, right? Because when I first started this channel, I had a few videos on just general combinatorics, and I showed the Catalan numbers, which were 1 divided by n plus 1 times 2n choose n, right? So if we want to generate these, right, we already have a generating function for 2n choose n. So let's think about a way we could get this n plus 1 here. I don't know how obvious it is to the most of you, but it is. I mean, I think there's another way to get this without what I'm about to do. But we can actually just integrate this, right? If we integrate term by term this generating function, we'll get new things, which are 1 over n plus 1 times 2n choose n times x to the n plus 1. Because when we integrate just a single polynomial term, what happens is that we we increase the power and we divide by the power, right? So this integration gives us the perfect tool because this is just Cn. This is the nth Catalan number. Now the only caveat is that here we see we have this is x to the n plus 1. But if we want a generating function, right, we want terms that are of the form Cn times x to the n. But this is no problem. We can just fix. So basically, the goal here is we're just going to integrate this function. That was the worst integral sign I've ever made. We want to integrate our generating function to get a new one. Find out what the integration constant is, because when we integrate this, we're going to have some plus c. We want to get rid of that c, and then divide everything by x, right? So we get this form, because we'll have cn x to the n plus 1, but we want to divide by x, but we have to get rid of the constant first. So let's just begin by integrating this, and this is I thought this was like some sort of fancy trig integral when I first saw it. It's been a while since I've done calculus, so I had forgotten that this is actually if you're if you're if you're integrating sort of 1 over a square root and you have a linear function in here, it's actually super easy. It's nothing at all. So what we have to do is multiply sort of the outside by 1 or negative 1 square root of 2 or negative 1 over 2, negative 1 half, and multiply the top here by negative 2. And then if we multiply top and bottom by 2 again, we see that this becomes a negative 4, and this is sort of the general. This is the derivative of this, and we have this 2 here. So basically, we can just integrate, and we get negative 1 half times the square root of 1 minus 4x. All right. So now we're claiming that this is equal to some constant. I'll say a. I know it's a sin to say a and not capital C, but we're already dealing with C's here. I don't want to give any confusion. And I also want to call the generating function for Catalan numbers C of x. So we're going to say that this is equal to some constant plus x times our generating function for Catalan numbers. So we need to figure out what the constant is. And this is just a deed for the general binomial theorem. And we see that if we were to expand 1 minus 4x to the 1/2 power, the first thing here is actually just negative 1/2. because this here will give us a 1. It'll be 1 plus something. So and that is actually, you can use Maclaurin series to say that this first one will be sort of f of 0, and if we plug in 0 here, we get 1. So yeah, so our constant is just negative 1/2. So now we have 1. So I'm adding 1/2 to both sides. So we have 1 minus 1 over minus the square root of 1 minus 4x over 2, and this is equal to x times c of x. And we want a nice way to sort of divide by x here. And what we can do for that is take the conjugate up here. So we'll end up getting 1 minus 4x. And that's going to be positive 4x, and I'll divide by the 2. So this is equal to 2x divided by 1 plus. So here we have the conjugate. All right. And then we can just divide by our x. So we have, in all, we get that the generating function for Catalan numbers is 2 divided by 1 plus the square root of 1 minus 4x. Yeah, that's it. I want to do one more problem with this, but I don't know how long it'll take. You know what? I'll do it. All right, so we want to consider the smaller root of this is a big number. It's 10 to the 6th here. Of the polynomial 10 to the 6 x squared minus 10 to the 6 x plus 1. And if we write that out, we get 0.000001, 0.000001, 0.000002, and yeah, so it's written out here. And we want to, what we notice is that we have the first 5 Catalan numbers here. And I believe this is C0. I should probably check that before going on. Yeah, that's C0. And so we want to know when the pattern stops. So it could stop with the next block, right? This could just be a coincidence. This could be completely unrelated to Catalan numbers entirely. But it's not. And so we need a better way to attack this than rather than getting a computer to sort of just list out the decimals, right? We want to know for sure. So what is the smaller root of this polynomial, right? So I'm just gonna use I'm sort of just gonna use a. No, I'm bad at writing A's. Let's think of what letter I can write the most. I'm just gonna write an O. No, that's too much like a 0. Dang. Okay, I'll stick with A. I'm gonna let A equal to 10 to the 6th because that's gonna show up a lot in this. So basically, we just use the quadratic formula, and we get that x is equal to A plus or minus the square root of A squared minus 4A all over 2A. And so our smaller root, right, notice that since A is a positive number, A squared minus 4A is less than A squared, which means that the square root here is less than A. So our smaller root, which will also be positive, is A minus square root of A squared minus 4A over 2A. And here we kind of see a little Catalan popping up again, right? And to make that more obvious, right, I'm going to divide top and bottom. That's not division. Divided by A and A. So And I know really that's multiplying, but you get the point. I'm going to divide by a on the top and bottom. So we get 1 minus, and then when we bring the a inside, we get the first one is 1 over, is 1 minus 4 over a, because when we take the a inside the square root, it becomes an a squared. So we're dividing by a squared. And then the denominator just becomes 2. But if we remember, we knew that x times the generating polynomial for Catalan numbers was 1 minus the square root. That's, no, the square root of 1 minus 4x all over 2. Perfect. So we know that x is equal to 1 over a. So what does this mean for us? This means that this root is, we're actually evaluating the Catalan polynomial. So we have 1 over a, and then an infinite sum of the Catalan number times 1 over a to the n. And why is this important? This is important because a, and specifically 1 over a to the n, is a power of 10, negative or not. It's a power of 10, so I don't know what happened there. So what we're getting is these numbers, right? And the reason, so if we were to plug in n equals 0, right, we would get c0, which is 1, times 1 over a to the 0, which is just 1. So really we should be starting out with 1, but we have this 1 over a. 1 over a shifts the entire decimal, right? And that's why we get blocks of 6, is because a is 10 to the 6. So we're dealing with 10 to the negative 6. And so really we think, okay, so if we've proved that this decimal, that this root is indeed related to the Catalan numbers, then maybe this process doesn't, or this pattern doesn't stop. But let's think about that more, right? If each number is taking up 6 blocks of space, what happens when we have a Catalan number that takes up 7 blocks of space? We can't just compress it, right? It has to take one of its digits and shove it into the other block of space, right? So this pattern stops whenever for the second to last Catalan number that has 6 or less digits, right? Because the 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 biggest Catalan number with 6 digits won't be in this pattern, right? Because its last digit, or at most its last digit will, or at least its last digit will be ruined by the one with 7 digits, right? Because it has to carry over to the other one, right? And so really at this point you have to look up sort of a list of Catalan numbers to find out which Catalan number you're referring to, but basically the pattern stops whenever the Catalan numbers become greater than 6 digits. That's sort of the general answer. Let's see. So this video was a little long, but not too long. I just wanted to sort of put in one video. I didn't want to make 2 videos on sort of a really related topic. So anyway, thank you for watching, and I'll see you in the next video. Bye.